So we're going to be looking at a continuation of the topic on circles. Last time we covered the basics, looking at the general equation of a circle, and then we looked at the point on the power of a point with respect to a circle. So we're going to continue on that vein. So let's do that. So the power of a point is just a real number that reflects the relative distance of a given point from a given circle. So and that's what we're going to be looking at. We'll look at if the point is outside the circle, if it's within the circle, if it's on the circle, and see what the power is like, and how we can derive the power of a point relative to the circle. So if we have such a blue circle here, and then we do have an external point, P, that is outside the circle. So we'll have a point P right here, and then there's a tangential point here, so that when we draw a tangential line from T to P and O to T, so the OT is perpendicular to TP. So if we draw OP and that crossing the circle at point R, then the power of this point is the same as the square of the distance OP minus the radius, which is OR squared. And since OR is the same as OT, so it's OP squared minus OT squared. By Pythagorean theorem, that's the same as PT squared. Now, the same circle, if that point P now moves into the circle, we can see that the power of that point is the same as OP squared minus OR squared. Since OR is greater than OP squared, we can now flip and put a negative sign outside, so R squared minus OP squared, same as OT squared minus OP squared, which is negative PT squared. So the power is positive if the point is outside, the power is negative if the point is inside the circle, the power is 0 if that point is on the circle, since OR squared minus OP squared will be 0. Now the power of P we found to be PT squared. Let's see a different expression that we can use. So if we produce the line OP so that it touches the circle at point A and point B, then the power is going to be, as we saw previously, OP squared minus OB squared, which is the same as OP plus OB times OP minus OB, difference of two squares. So OP is the same as OB plus PB, then plus OB. OB is the same as OA, so we have this OB plus OP plus OB being equal to PA, so the product of PA times PB is the power of this point. So PA times PB. And then if you move this so that it does this line so that it doesn't touch the center, we still find that the power is going to be PA times PB. And we're going to prove and show why that is the case. And then if the line moves further so that it only touches the circle at one point, we see that it goes back to the definition of PA squared or PB squared or PT squared as we saw previously. So now let's prove and show why if the line still crosses the circle at point A prime and B prime, the power still remains PB times PA. So this theta 1 is the same as theta 1 here, since this is a cyclical quadrilateral, and we see that opposite angles add up to 180 degrees. So 180 minus theta 1, so this becomes theta 1, and this theta 2, so this angle at B prime is the same as theta 2, and by the sine rule, PB over sine theta 2 is equals to PB prime over sine theta 1, and so we can clearly see that PBA prime here over sine theta 2 here is equal to PA over sine theta 1. Sine theta 1 is here. And so rearranging PB over PB prime is sine theta 2 over sine theta 1. PA prime over PA is sine theta 2 over sine theta 1. And so equating this PB over PB prime to PA prime over PA means that the product of PA and PB is the same as the product of PA prime and PB prime. And so that is how you prove that it doesn't really matter whether you are looking at the second line that crosses the center or that is away from the center, or if you're looking at the tangential line or the tangent line that touches the circle. So this is just a quick summary of the point, the power of a point relative to a circle. It is the product of the distance from that point to the extreme end where it touches the circle, and the distance between that same point to the point that it touches the circle nearest to it. So that is it. Until next time, I hope you stay locked. Bye-bye.